Hello guys, I'm a teacher Limboka Sidigo Masame. Welcome to Limboka Physics. Let's today look at questions below. A certain refrigerator converts water at 0 centigrade degrees into ice at a maximum rate of 5 grams per minute. When the exterior temperature is 15 degrees centigrade, assumes that the rate at which the heat leaks into the refrigerator from its surrounding is proportional to the temperature difference between the exterior and the interior, and is 2.5 watts per degree centigrade. What is a maximum exterior temperature at which the refrigerator could just maintain a temperature of 0 degrees centigrade in interior? Given specific latent heat of fusions of ice as 33.0 kilojoules per kilogram. Okay, in order to attempt these questions, I just decided to underline each statement with a given color. These red ones represent the first two conditions for these questions, green one represents the second condition for these questions, and the purple represents the third conditions where we can have to find the solutions for the required questions, for the required answer. Let us follow the step according to these colors. The first condition is heat absorbed or released at 0 degrees centigrade, which is equal to heat transferred from the external environment. As you can see from this diagram, this is heat from a change in temperature. This is temperature from the exterior, which is 15 degrees centigrade, and this heat leaks interior of freezing compartment, which is containing ice water. This is circulations of liquids where at a point become vapor and at a point become liquid, as according to mechanism of refrigerators. You may refer from the book. Okay. When the second condition is the rate of heat leaks per degree centigrade is proportional to difference in temperature. Let us deal with this second condition. We simplify the second condition as the power per change in temperature. As you can see, the rate of heat, this is power per change in temperature, proportional to change in temperature. To its respective physical quantities, of power P divided by change in theta, proportional to change in theta. When you remove proportionality constant is P divided by theta simply square. Now let us take P per theta as S, then we have K is equal to S divided by change in theta. Okay, when we deal with these first equations, when we have a heat absorbed or released at a constant temperature, which is 0 degrees centigrade, which is equal to heat transferred from the external. Okay, its rate per temperature is power per change in temperature. As we can define this power, as you can see now, the rate of water conversion to ice is mass divided by time, now times change in temperature, as this also is equal to S, as we have assumed here at the first condition. At these conditions that occur in interior of the freezer is where now we have a new condition, the last condition underlined by purple color, that what maximum exterior temperature at which the refrigerator could just maintain a temperature of 0 degrees centigrade in interior. For this case, we say that its power per change in temperature theta dash for the interior to remain 0 degrees centigrade. This is as a nasty condition, the third conditions, where the new change in temperature, which we assumed is a change in theta dash, is the difference between the temperature now as indicated here. We must remember that the new attained temperature must be equilibrium temperature. After the interior remaining 0 degrees centigrade, the exterior must keep gaining heat from the interior, so that the interior will remain 0 degrees centigrade. Will continue converting the water into ice at a rate of 5 grams per minute, so that exterior must gain heat as the change, as we will have new change in temperature, and this new change in temperature as we will have equilibrium temperature minus the original temperature, which is 15 degrees centigrade, the original exterior temperature. Okay. And this is what I summarized here. For this change in temperature, when interior temperature must remain 0 degrees centigrade, and this is at equilibrium conditions. Now, the power as usual, as we have explaining this flow and getting this constant, is also we will get this constant here, because this power per change in temperature is also proportional to change in new temperature. To change in new temperature, we can define this power as you can see here, and we may assume this is another equations, because this K will be constant. First, before assuming this is another equations, we know that K is constant for both cases. Let us find K from the first case, because from the first case we've given the values, somehow value of this K as 2.5 watts per degree centigrade. This is value of power per change in temperature. Then from K is power per change in temperature, which is S, divided by change in temperature. Then we can easily find the power now, because change in temperature from first case we have 15 degrees centigrade minus theta minus 0 degrees centigrade, because the interior is 0 and the exterior is 15 degrees centigrade. But this joules per second, we must find changes per second into minutes, because the aim of this question is converting this water into ice with 5 grams per minute. Let us consider our calculations with minutes instead of seconds. Then when we change into minutes, this second into minutes, now it is be 1 over 60 minutes. Then we do mathematics here and get 10 joules per minute per degrees centigrade square. Okay, because this is constant rate of heat flow per square degrees Celsius in minutes. Okay, it is constant. Now we take constantly to this first equation here, as you can see here. Then for these new conditions, we will substitute the value for rate of mass conversions of water to ice, then times latent heat of fusions, then divided by change original change in temperature, then equating to 10, then times new change in temperature. Now from new change in temperature, as we have explained before, these ones will be defined as theta in equilibrium minus 15 degrees centigrade. After getting the answer, which is 11 centigrade, as new change in temperature, then we come to these expressions, and the new exterior temperature, when theta interior is equal to 0 degrees centigrade, is equal to change theta in exterior, which is from first condition, plus theta dash changes. Now what we'll have here, which is equal to 26 degrees centigrade. Thank you for watching. Please like, share, comment. Don't forget to subscribe this channel for more video like this one. Thank you.